Hello guys, my name is Lazaro, and today we'll be going over a LeetCode problem. This problem is called prison cells after n days. There are 8 prison cells in a row, and each cell is either occupied or vacant. Alright, so we know it's always going to be 8, so that's pretty good. We know there's a constant. Each day, whether the cell is occupied or vacant, changes according to the following rules. If a cell has 2 adjacent neighbors that are both occupied or both vacant, the cell becomes occupied. Okay, so if the cell to the left and to the right, if they have the same value, then the current cell we're looking at becomes occupied, aka becomes 1. Otherwise, it becomes vacant. Okay, so if the cell to the left and the cell to the right does not have the same value, the current cell is becomes vacant, aka becomes 0. Note that because the prison is a row, the first and last cells in the row can't have 2 adjacent neighbors. Of course, so the first row only has 1 adjacent neighbor, and so does the last one. You are given an integer array cells where cells of I equals 1 if the ith cell is occupied, and cells of I equals 0 if the ith cell is vacant. So this is telling that a vacant cell means that it has a value of 0, and an occupied cell has a value of 1. We are also given an integer n. Return the state of the prison after n days, i.e. n such changes described above. So after n days, uh, for every day we apply these changes following these rules, and we want to return the cell or the state of the prison cells at that nth day. So let's look at an example. Here we're given cells and we're given n is equal to 7. And on the 0th day, we have this one right here. But on the next day, things changes. As you can see, this 0 does indeed stay 0 because it has no adjacent. It doesn't have 2 adjacent neighbors, as noted right here. And then the 1 stays a 1 because its 2 neighbors have the same value, which follows this rule. 2 adjacent neighbors, either both occupied or vacant, and the cell is a 1. Right here, its neighbors are vacant, both of them, so it stays a 1. For this 0, both its neighbors are occupied, so this value does indeed change on the next day. It goes from 0 to 1 as shown right here. Now this 1 of its neighbors is 0, the other neighbor is a 1, so this turns into a 0. Same thing goes for this one up here. This 0 and this 0 is the same thing. And this cell at the end doesn't have a any neighbor. It doesn't have 2 neighbors, therefore it changes to a 0. So now this goes on for a couple more days following these rules, and we're left off with this array, with this state of the prison. Now this might seem like Conway's Game of Life, and that's because it kinda is. There's certain rules that we have to follow. Let me close that. There's certain rules that we have to follow that determine the state of a cell, whether or not it's occupied or vacant. And that rule is dependent on its neighbors, just like Conway's Game of Life. So you might think this is pretty easy. Well, you just apply these rules for n days, but there's a twist. The twist, as you can see, can be shown right here, and you can also see in the constraints where n, the amount of days, can be as big as 10 to the 9th. So that's, I believe that's 1 billion, and that's a lot. Most LeetCode solutions, they give you a time limit of 1 second, maybe 2 or maybe 5 at most, and having a for loop that runs for a billion iterations most likely takes longer than that amount of time allotted to this problem. So how can we solve it? If there's already a problem with the constraint, what do we have to do? Well, just like in Conway's Game of Life, there might be cycles that appear in this uh, in the cells, and that cycle, as soon as we see a cycle, we no longer have to compute the rest of the days, because we know that once we enter a cycle, we can figure out with the remaining days left where we're going to land in that cycle by using the modulo operator. So what do I mean by this? Let's write it out. I actually forgot to delete this from the last problem. Okay, no problem. It's pretty easy. So let's say let's not really write out an array example. Instead, let's just focus on the days because that's the important thing for solving this problem. We can easily handle updating the cells, but what we have to worry about is finding that cycle and knowing how to treat that cycle, what to do with it. So let's talk about the days. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hopefully you guys counted with me. uh, so let's say we have 12 days, right? And we notice that on the fifth day, it repeated the pattern that we saw on the second day. Now this gives us a good amount of information. First off, what does it tell us? Well, if it tells us that, let me use a different color. It tells us that the remaining days that we have that we want to really care about, including the cycle, starts from here all the way to the end. Because this is when the cycle started, and this is when we detected the cycle. Now, what else do we know? Well, we also know the length of this cycle. If we know that it repeated at 5, and we first saw that cycle at 2, well, we know that the length is, choose a pretty color here. Ooh, none of these are pretty enough. I guess I'll use green. It's very neon green. We know the length of this cycle is right here. Oh, actually, it's more like this. Sorry. There we go. Because here it's restarting the cycle, so this 5 kind of represents this 2, and they're the same thing. So it's more like these first 3 right here. So what? What does this mean? Well, we cannot figure out how many of these cycles are in the remaining days, are in this red colored days here. And let's actually figure it out. So we can fit 3 in the beginning, 3 here, 3 here, and then 2. So we can, another way we can figure this out uh, programmatically is by using the modulo operator. In total, there's 12 days, and it started on the second day, so 12 minus 2 is 10. There's actually 11 here, but that's fine. So let's just write out that 10, because we want to take the total amount of days, so we want to do n minus the day it started. So it started right here. Oops. So n minus started. This is the first piece of information that we want. So this is, let's say n is equal to 12. So 12 minus 2 is equal to 10. Next, we want the length. So let's say we detected it here. So we want to do detected minus started, and this would be 5 minus 2, give us 3. Now we want to do the modulo of these two. So 10 modulo 3, that'll be 1. And of course, this would be appropriate. I think I messed up the greens right here, but this red line, you know what? Let's actually fix it. There we go. So red line would be coming up to here. Then the green one be more appropriate if I drew it out like this. So it's for those first 3, this first 3, then that one, and then just this single one. So that's why the remainder is just 1, because at the end we only have 1 remaining. Now, if this is the case, we want to also take into account, oops, let's go back here. We also want to take into account the date that we actually saw it. So the answer is just not going to be 1, it's going to be 1 plus the date that it started, and that will give us 3. So this is saying that the answer is the pattern we saw on day 3. And let's actually confirm that. First, I'm going to remove all these lines. I'll keep the circles. I'll keep the circles, but I'll remove the arrows. Perfect. So we're predicting 3, where we detected it on the 5th, and it started on the 2nd. So let's go through this. So we see 1, we see 2, we see 3, we see 4, we see 2 again. This is basically 3. This is 4, 2, 3, 4, 2, and then 3. And that is in fact the correct answer. Because if this cycle is repeating, we would have something like this. 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3. And that's pretty much the main thing about this problem. It's that we want to detect when we see that cycle, and we also want to know when's the first time we saw that cycle. So let's get into the programming. Now we know the magic trick to solving this problem. So let's see how it's going to look like. I have it here off to the side just to make sure I don't mess anything up. So we want to keep track of the day we saw this specific pattern, and yeah, so we want to keep track for this pattern, what day did we see it, and we also want to do the reverse. On this day, what pattern did we see? So we're going to want 2 hash maps to keep the lookup efficient. So we have states, and we have day 2 cells, and let's call it 2 states. And then we also want a day variable to keep track of what day we're on. Now let's iterate over n days. And now, how can we store the cells in our hash map? Because of course we can't have the key as a list. We need to have something that's hashable. An example could be a string or an integer. So for these cells, there are values of, for example, something like this, 3, 6, 7, 8. If it's like this, for example, you can turn this into a string of just exactly what it is right there. Or you can take this as a binary number and convert it to whatever what number this represents. And that's actually going to be the route I'm taking. So I'm just going to call this cells bin. So cells binary number. You guys feel free to do the string if you want, or you can do this one as well. So for every cell in cells, we want to add it to our cells bin. And first we need to shift it to the left by 1 and then add cell. So whether it's 0 or 1, it will add it. This is like the OR operator, or adding the 1 at this location. It's more accurate if you say adding the 1 actually. Alright, so that's going to be that right there. Now we have kind of this hashable representation of this prison state. Now, if we've seen this before, what do we want to do? Well, we want to get the date that we saw this state, this prison state. And that's going to be inside of our hash map called states. So let's retrieve it. Now we want to do that arithmetic. So let's get, let's call it remaining days. That's going to be equal to n minus last day. So let's do cycle length. Let's call this cycle length. And that's going to be equal to the current day it is minus the day we saw the cycle. And of course, we want to call the result of this. We want to do remaining days modulo cycle length plus the offset. And of course, in this case, the offset is the first day we saw that cycle. Let me make sure I have all my variables correctly. There we go. Now what we want to do is return the cell state at this day. And for this, we want to use our day to states hash map. And that'll be it for that case. But let's say this doesn't go through. If we have not seen this cell state before, well, we want to add it to our states hash map. And we want to also add it to our day to cells hash map. So this is kind of we're using two hash maps. One is kind of the inverse of the other. Let's also increment the day, because for the next iteration it's going to be the next day. And let's update cells. So we want to update cells according to these rules. And for that, I'm just going to break it up into a different function. So the new array is always going to be of length 8. So we can create an array of length 8 with all initial zeros. Just like that. It's that easy in Python. And now for I in range of 1 to 7, cell underscore value is going to be initially to 0. And I should explain the reason we're doing 1 to 7 instead of 0 to 8 is because remember that no matter what value it is initially, if it's a 0 or 1, on the second day, the first and last cell is going to be turned to a 0. Because since it doesn't have two adjacent neighbors, it will be forced to be a 0. So initially cell value is equal to 0, but if cells of I minus 1 is equal to cells of I plus 1, then cell value will equal 1. So if the two neighboring cells are the same, aka they're both vacant or they're both occupied, then the current cell we're looking at will be 1. This is all we really have to do. From here we can just return new cells. And now we can update cells and set that equal to whatever this function returns. Now, from here, we're pretty much done. And we can just return cells. Let me run this to see if I made any mistakes. Okay, date to states. Oh, yep. I missed. I did date to cells. Let's run it one more time. Perfect. So it gets accepted for the first example right here, and also for the second example, which is where that n is equal to a billion. Yeah, a billion. So now let's submit it and see if this is actually fully accepted, and it is. Perfect. All right, my mic turned off, but yeah, hopefully this helped you guys understand the problem. It was pretty tricky, but the main key to solving this was really understanding that their cycles could occur, and once a cycle occurs, you have to figure out this arithmetic just to deal with it and to see what answer will be the correct one. So yeah, it was just the cycles and the mapping that was really tricky. Other than that, the rules are pretty straightforward. So yeah, hopefully this helped you guys, and now you guys were able to solve it. But other than that, thank you guys for watching the video.